In this video, we'll be talking about how incomplete dominance works in a genetic cross. Overall, the definition of an incomplete dominant trait is when we have a genetic cross for a trait where neither allele is going to be dominant over the other. So we're not going to be able to use a capital letter and a lowercase letter, and we will not see that one allele masks another. What ends up happening is when we do get the heterozygous form, or one of each allele, we will see a combination of what they look like. An example of this can be found in flowers. Red is incompletely dominant to white. So when we go to make our key, we want to use two capital letters. We're going to use big R to represent the red gene and big W to represent the white gene. Now overall it should make sense to us that if someone is RR, or I should say a flower is RR, they would be red. In the same way, if someone was WW, they would be white. However, when we see the RW, the heterozygous form, we're going to see a combination of the two. This is where we would see red and white mixed together, and this would create a pink flower. Let's take a look at a couple examples of this. We want to cross a red flower with a white flower. The genotype for a red flower would be RR, and we want to cross that with a white flower, WW. So let's set up our Punnett square. In our Punnett square, we are going to want to write the alleles, or the gametes, for one flower here and the other here. So I'm going to put this first one here, R and R. They are going to pass down either a big R to their new seedling or another big R to the seedling. The other flower would pass on a W or a W. We would see when we go to fill in the Punnett square, all of the offspring end up being RW. So for our genotypic ratio, we'd be able to say that they would all be RW. When we want to take a look at the phenotypic ratio, we have to remember that we have this heterozygous combination, and we're going to see that all flowers would be pink. Let's take a look at one more example. In this case, we're going to cross two pink flowers. Pink flowers would be RW crossed with RW. When we go to set up our Punnett square for this, we would see that each parent flower could pass down an R or a W to their offspring. And when we fill in the boxes, we see that it's going to be much more varied in this case. For our genotypic ratio, we're going to see there's one big R offspring, that's right here, to two RW, to one WW. Now when we go to write out the phenotypes of this, we have to again remember that this combination, this heterozygous form, will be different. We would see there would be one red flower out of the four, to two pink flowers out of the four, to one white flower. Overall, incomplete dominance is very similar to the different crosses, the monohybrid. However, the main difference here is when we have that heterozygous form, and that's going to show the mixture of the two alleles. There are many examples of this, and you'll be discovering them as you work through the practice problems or when you take the quiz.